I hope that you completed the problem. If you haven't, please push pause and try to complete this problem. Otherwise, I will go ahead and do this. So we're trying to find an approximation of the root of the following function with an initial approximation x0 of negative 1.5. We're going to use 3 iterations to go ahead and do that. I like to take the derivative right up front just so that I can do the problem a little bit more efficiently and more quickly. So my g of x is x to the 5th minus 5x minus 2. That means the derivative is 5x to the 4th minus 5. My initial guess here is negative 1.5. If I plug that into my function, I end up with approximately negative 2.09375. That's not a root. X0 is not a root because I don't get 0 as my output. The derivative of that function at negative 1.5 is 20.3125. In order to get one iteration using Newton's method, I take my initial guess, negative 1.5, minus a certain fraction. That certain fraction has a numerator of negative 2.09375 and a denominator of 20.3125. I go ahead and calculate that number. I ended up with negative 1.396923. That's when I round things to 6 decimal places. Now that I have my first approximation, I find what would happen if I plugged in that number into my function. I ended up with negative 0.3347812. And while that's not 0, it's a lot closer to 0 than we were previously. If I type negative 1.396923 into my derivative, I end up with 14.03969. So that's the first iteration. The first iteration, I get this. The second iteration, well, I'm going to do the exact same thing I just did, but now with the output of my first iteration. So negative 1.396923 minus the fraction whose numerator is negative 0.3347812. Oh, I was supposed to round that to 6 decimal places. Let me round that to 6 decimal places. Sorry. And whose denominator is 14.03969. I hope that's rounded to 6 decimal places correctly. By that, I mean, like if you rounded to 6, you just get a 0 there. 6 decimal places, you get a 0. So we calculate that. negative 1.373078. That's my second iteration. So that's my second guess. Let's go ahead and see what happens when we plug this number into my function. Well, when I plug in that number into my function, I ended up with something that's very close to zero, negative 0.015242. When I plug that into the derivative of my function, I ended up with 12.772595. So let's try to get our third iteration. So that's second iteration there. Let's find our third iteration. We're going to take our second iteration minus the output of our function when you input the second iteration, and the output divided by the output of the derivative when you plug in the second iteration or the second guess. So x2 we see is negative 1.373078 minus fraction, numerator of that fraction is this thing, denominator of that fraction is that. So let me calculate that. I went ahead and did that, and I got negative 1.37188.5, rounding to 6 decimal places. Notice that we're getting really, really close. You know, we're kind of honing in on a really close guess now. We went negative 1.5 down to negative 1.396, now negative 1.373, now negative 1.371. You're getting closer and closer all the time to the real answer. And just to show you that we're continually getting closer, let's take and plug in my guess into the function. So take my value of negative 1.371885, plug it into the function, and that's where you start getting out scientific notation, negative 4.089 times 10 to the negative fifth is what I ended up with. So we're very, very close to zero. All right, so we're very, very close to one of the roots of the function. So you can see how this method, in particular Newton's method, gets you better and better approximations. There is a slight downfall of Newton's method that you can see in this example. One of the downfalls is that this is going to give you the root that's closest to negative 1.5, but this is not the only root of the function. So there are multiple roots of this function here. And depending on where our initial guess is, it will force us into one of those roots. So if our initial guess was 2, we would have gotten a different root than at negative 1.5. If our initial guess was 0, we would have gotten a different root than starting at negative 1.5. So it is very dependent upon which initial guess we use. Let me show you graphically what's going to happen. I have graphed the function x to the fifth minus 5x. I put y equals, but you could just have g of x equals. It's the same thing. G of x equals x to the fifth minus 5x minus 2. You can see that the root we're getting is the one that Desmos rounds to negative 1.372. But if we would have started somewhere along this path here, we would have ended up with this root. And if we would have started over here somewhere, we would have ended up with this root. Now, here's another little odd thing that could happen. What if we started at a relative maximum or a relative minimum? Well, we would have ended up with a derivative whose output is 0. In other words, we would have had horizontal tangent lines there. And if we would have had horizontal tangent lines, that would have thrown us all off. So for instance, if our initial guess of x0 was negative 1, well, if I would have plugged that in to the derivative, I would have gotten 0, and I would not have been able to use Newton's method. So Newton's method is dependent upon us not starting at a relative minimum or relative maximum or anything whose derivative is 0. So we don't want derivatives to be 0 in Newton's method because we are dividing by that number. And that's going to cause us problems if we ended up at a relative minimum or a relative maximum. All right. So if we did start at a relative minimum, relative maximum, critical point of any kind, then you could just move over left or right a little bit and change your initial guess by a little. But as we saw, if you change your initial guess by a little to the left, you might get one root. And if you change your initial guess a little bit to the right, you might get a different root. So that's how we go. Hopefully that makes sense. So if I started over here, tangent line would be negative. If I started to the left of negative 1, like I did, tangent line is negative, and it's going to give me this root. Or excuse me, tangent line would be slope would be positive, so I'd be going the left and getting this root. If I started a little bit to the right of negative 1, I would have ended up getting this root here.